Good morning and a warm welcome outside there to the US from Germany. At my side, my dear colleague and good friend, Daniel Brown. How are you doing today?
Good man, good. Chris, good to see you here as well.
Thank you, thank you. Yes, my name is Chris. I'm also doing pretty good today. As we see in Germany, it's around pretty late right now and it's getting dark. So you are at the start of the day, we are at the end of the day, but still we are happy to be here with you guys and giving you a good show. On what? What's the topic of today?
So today's webinar is actually the second webinar that we're running. So yesterday we did ADAS and today we're going to have a look at hybrid electric vehicles with in a particular focus on the ASE L3.
Okay.
So having a look at the specialist test that's been around for a few years now, and we're going to have a look at not just the L3, but we're going to have a bit more of a deeper dive into the technology today as well. So looking at how the electric vehicles work.
Perfect. And this will be followed by tomorrow's webinar then, which is focusing what?
That's then going into high voltage batteries. So that's really then a deep dive into the electric vehicle. So
Hot shit.
yeah, so even though this one's going to be having a look at things like three-phase motors. So we know three-phase motors work without brushes, things like that, induction motors, permanent magnet motors. We know that they run with three phases or three-phase electricity, which is usually AC. We have batteries, of course, so how do we get that AC from DC sources?
So more or less a complete look on the high voltage system of a certain car. We have, different examples for that, and you will see how this very complex and new topic will be introduced by our training systems. So talking about high voltage system and high voltage cars, I mean, what is the challenge and what are the demands? There are people outside who are experts on high voltage, like you are, for example. There are people who have done a little bit with it, and there are also a lot of people who haven't touched high voltage.
Yeah, absolutely. So it's obviously a big challenge. We're talking about automotive technicians, so actually we haven't introduced ourselves. Maybe you were on the webinar last night. Daniel Brown, originally from Australia, automotive technician with Toyota, and then got into teaching as well. Was a customer of Lucas-Nuelle in Australia, buying the equipment that you see here. Ended up working for him as well. So,
and
Chris,
now
You've just achieved your 10 years here in the company as well.
That's right,
Congratulations.
Even if you do not look that old, maybe.
Wow.
So that's right. I'm now for 10 years here in the company and being part of the team for the product management for automotive. I come more from the study university side. Daniel is more the mechanical, the hands-on guy. And this is what we have done more or less the last 10 years, that we have, focused and combined our powers and energies and just did the best out of it.
So what's been really interesting here with Christian as an engineer, so don't be shy, you've got your engineer qualifications.
I think so, yeah.
What that helps is I've got the practical background, you've got more of the theoretical, so what we're able to do is then understand a little bit more deeply how this topic really comes about, because we're talking, a lot of the things that we're talking about for hybrid electric vehicles are outside of the vocabulary for automotive guys.
That's right,
We start talking high voltage. Electricians normally deal with high voltage. We start talking inverters, things like that. So obviously a lot of electronics. So it's good where we can sort of combine our skills and competencies to put together the e-learning and the hardware to do that. But today we're not doing a sales pitch. We really want to do some training for you here. We'll do a live Q&A probably towards the end, I would say. Otherwise, so it doesn't break down at all. But if you got any questions, you can write them down at any time. And if we see them, we'll go through and answer them on any particular topic that we're covering at the moment.
Absolutely.
The webinar, as long as you guys stay around, we could be here. So I'd say we need at least an hour, but we could go for 2 hours. So we'll see how we go.
Perfect.
Talking about the challenges though.
Yeah, exactly. So I just,
question?
when we're talking about these things, I just have to remember Skills USA last year, for example, where we have been with our training system or with our trainer, which we'll see later, the ASE L3 trainer. What was very what was very important for me to see that there were some students, everyone did pretty well, but there were students who were like, high voltage, yeah, I did a lot with that. And there were a lot of students who were really shaking in front of it, and they were like, wow, never touched high voltage before. And you could see that they were basically afraid.
Yeah.
So this leads me to the question. We have here brand new vehicle, Audi Q5 hybrid. So basically, we have here a car with a combustion engine, with bus systems, with driver assistance systems, and with a complete high voltage system. So why shouldn't we use just that car for doing this ASE L3 trading?
Well, if you have a look at it, and we'll go into detail what that L3 task list is. So not everyone's seen the PDF that you can download from ASE yet. We'll go through that and show you what is required to pass the test. But if you have a look at a real vehicle, especially late model vehicles like this, it's getting harder and harder to see what's actually going on inside. So this is an Audi hybrid, and essentially what we can see here, which gives us any indications that it's high voltages, we've got a couple of stickers here, and I can see at the moment one orange cable. So the electric motor would be down the back here. Battery is hidden away in the back of the vehicle.
Absolutely.
And when it comes to really understanding, so there's certain things we can sort of train people up in order that they can do something, a particular task, or we can train them up so that they understand. And I think I spoke about this last night, and I'll say it again because we don't have the same people that are here, but I can really say the German philosophy when it comes to training, we all know about the German apprenticeship system, the dual system that they talk about, where the word apprentice means that you get a job first, you start working on the job, and then you begin your training. And there's a whole, there's a very long history of apprenticeships here in Germany, and there's a real focus on making sure the young person that's getting trained gets trained completely. So they're not being trained for one particular job,
yes,
as in one particular job of a certain trade. They're really learning the whole trade. So there's a deep, understanding of the systems, and that's what they call system understanding. And so that's what we try to bring into our training systems here at LN.
And now, as you said, especially it's absolutely about this deep understanding, this getting the whole picture of it. But especially if we are talking about hybrid electric vehicle and the high voltage system, and you even said, okay, we're going to touch the high voltage battery even later on, or basically tomorrow in this webinar. But what about how would you describe the challenge on such a real vehicle when it comes down to the high voltage safety?
Yeah.
Especially when someone is touching it who has no idea of it, and then you have even one teacher, one instructor, and he has to take care of 10 people, 20 people, and you maybe have 1 or 2 cars. So what is the challenge there if we are talking about the safety aspects when it comes down to hybrid electric vehicles?
So obviously we're talking real high voltage. So on a vehicle, you've got the batteries. Batteries are now running in anywhere between 100 volts to that new Hummer that we looked at.
Yeah, I just thought about it. 800
volts. So 800 volts DC. That's massive. You short circuit that, there's going to be some issues. But even the most common vehicles we see now, the Prius, the Leaf, things like that. Tesla. Looking inside the batteries, yeah, of course, we've got real high voltage there. But you've also got the problem which vehicles are not made for training. So they're not really designed. They're designed to be safe, actually.
Of course.
So they put layer upon layer of safety on top of them. So of course there's interlocks, so that if you inadvertently open something, they shut down, which is good. But they deliberately cover things as well. They make sure that they're covered with, the battery is always usually sealed somehow. And so you've got to do a lot of work to the vehicles to get access to them, and which it's not a bad thing. And we have plenty of vehicles out there where you do a lot of preparation to make sure, in training colleges and things like that. But if you start doing that with hybrid electric vehicles, you know, are you accessing places that are safe or not? Obviously, also taking measurements. You know, we can't take any measurements really easily or safely on the three-phase motor to see what the signals look like as well. So, you know, if you start pulling apart cables or,
Yes.
or worse, you know, probing three-phase high voltage cables could be a little bit of an issue.
That would be definitely a big problem.
Yeah.
So what I see so far now is like, okay, when we want to learn something about hybrid electric vehicles and we are using such a car, at the first step it's very hard for us really to see the high voltage system. When I have no idea of what the high voltage system is, for me it's very hard to understand how this is integrate into the car, because it's basically hidden.
Yeah.
The high voltage cables are running under covers, for example. It's not like that you always can see them. As you see, the main idea of the car manufacturer is to hide everything which is orange, so that the normal customer, the normal driver can't touch it basically. It's also a problem about when we are talking about training on hybrid electric vehicles, it's always about doing diagnosis and repair on it. So here's another question then. I know it from earlier times when we have combustion engine cars or just normal test engines. It was easy to put in some faults, for example, like the mass airflow sensor was broken or the lambda probe had a problem. You just did a bad wiring, a bad connection or anything like that. Now we are talking about a high voltage system where we have, like we said before, up to 800 volts, hundreds of ampere running through the system.
Yep.
I can imagine that the connections between the single high voltage couples are not just normal connectors like you know it from a 12 volt system.
No, sir.
And I also can imagine that it's a little bit problematically when you just put faults or simulation, when you want to simulate faults inside the high voltage battery, for example.
Yeah, absolutely. So obviously the connectors, they're not just simple pull apart connectors. So they're surrounded by something called an interlock. And we'll go into a little bit more detail about what an interlock is and how that works as well. So if you pull the connectors apart, they usually got big long connectors inside that will displace or pull apart the interlock before you pull apart the high voltage. So that is a sign to shut down. So that will, for example, open up the system main relays, which is something we'll also have a look at later.
Absolutely.
So then on the other side, you've got the problem that not a lot of scan tools are keeping up with electric vehicles now. So we've had plenty of schools over the years that have bought hybrid or electric vehicles, and they've got a scan tool, but it's not up to date and it doesn't have those vehicles. So if you put the faults in there, you can't access that vehicle and then delete the codes. So there's workarounds for that, but you know, it's a bit of a pain. And so
basically you need the tester by the car manufacturer directly really to get a deep look into the system and get a deep access to it basically.
And what I do want to say here though is that we're not trying to replace the vehicle. You still need the competency to fix the vehicles. What we are trying to do with our training systems is show or to teach the students a little bit more knowledge.
And we roll out the red carpet towards the car basically, so that they can go it when it's not about being in fear of hybrid electric vehicles, it's being respecting them basically. Know what the dangers could be, but also knowing when I keep up with the safety rules, I'm more or less, there's no 100% guarantee that everything works fine, but basically when you keep up to certain rules, then you're on a very good side that you can easily operate and do diagnose on these kind of cars.
So your example was good about Skills USA, and I've heard this from other teachers as well, not just at Skills USA, but so we had students. Skills USA, I'm sure you're all familiar with. This year would have been our 4th year with the section station, hybrid and electric vehicle safety. And we've had students every year so far, and these are the best of the best, don't forget. So this is the national program at Louisville. We're still getting students that are removing service plugs without the gloves. They look at the gloves, they have no idea what are the correct gloves, what are the wrong gloves, the measuring devices, all these sort of things. And so that was a real wake-up call for us. Some of the best students, and you know, we've got the document right in front of them that tells them what they need to do.
Yeah.
And so it kind of shows me that when they're going out to the real world, you know, get their jobs, and then they're going to be under even more pressure. You know, you've got the service managers saying, look, we've got to get this car out, or they get given, you know, all of the gloves or no gloves. Do they understand what they need to do before they get out in the real world? And so,
as you say, yes,
what we're trying to do is kind of give or impart a culture of safety so that they know and understand before they get to the real cars what they need to do.
So in other words, it's so important for them. Even you can give them the handbook where it says word by word what you have to do. In a situation where you are under pressure, where you have time pressure and all these, all day things which happen to you or which have an influence on you, even there the best handbook won't be of much help if you have not the fundamental knowledge which will tell you what you have to do, that you know how you can protect yourself, how the high voltage system of a car principally works, and how you can do different measurements on the car.
Yep.
And on top of that, of course, the car manufacturer specific informations, you have to read them and to use them. But as you say, the most important thing is to create this culture of safety by creating a correct knowledge base, fundamental knowledge base, where you basically can touch every high voltage car without bringing yourself or someone else in dangers. I just thinking about that, especially we are talking here about cars in a good condition.
Yeah.
It gets even more interesting when we are in a certain situation at the workshop situation, short before the end of the shift. So everyone is looking for the home time, and then a car or tow truck is coming and just bringing up a damaged Prius or something like that. It's not like before that you just can say, okay, bring it into the workshop, we take care of it tomorrow. There are real issues which we also will see later and even tomorrow.
Yeah. So that is talking about creating some confidence in the student as well. And so, excuse me, the teachers, so we've got a lot of these units in the US, and we're getting a lot of teachers are telling me what they do, right, is the students, when you're working on a real vehicle, so the shutdown procedure, which we'll go into detail about, there's a step where you need to do a live, dead, live test. And that's where things get serious, because you have to really measure the live high voltage somewhere on the vehicle. So that's changing a little bit with newer vehicles. That happens internally, but with most vehicles on the road, there is a point where you can measure the high voltage. And when you've got a classroom full of usually, you know, young men,
powerful men, yeah,
it's can be a bit of a worry when you've got, say, 16 of them in your class. You have to watch that guy like a hawk on what he's doing. And sometimes we get a little bit overzealous telling them, don't mess this up, like this is real. All of a sudden, you know, we've got the feedback I'm getting, the students, and now all, you know, they're shaking as they're doing that. So we don't want that as well. We don't want to scare them. We want to give them the confidence. And so teachers are putting the students in front of the car train here and saying, just do it 20 times. You know, get used to what are the gloves, what are the measuring devices, doing the one hand rule, live, dead, live testing and things like that. So
many points which you basically have to know.
Yeah.
So basically when we sum up, so at the real car, basically there is everything, but everything is there in a way which makes it hard to train.
Yeah.
So we have talked about interlock stuff, we have talked about the setup of a high voltage system, we have talked about the single components of a high voltage system, how you can identify a high voltage system, doing repair and diagnostic tasks on a high voltage system, and of course the most important thing, doing the disconnect procedure. Mm-hmm. There are certain ways of doing that right now out on the road at the different cars. So the question is now, it's hard to bring that across through a real car. So what will we see now? How we can solve these issues, and how can we teach that in a very safe environment, not on the car? So, but where are we doing it?
Yep. So I think we've talked long enough. So we'll go over and have a look in our high voltage area here now.
Exactly.
So this is what we've set up as our high voltage area. So, for example, in Germany here, there's very strict rules about setting up the any high voltage battery, for example.
Absolutely.
There's very strict rules as far as having it set up with bunting in its own room where people can't access. There's licensing that's required for who can work on the various stages. So it's not just split up into working on high voltage vehicles. There's people who might be just involved with a high voltage vehicle full stop. Then there's people that can shut down the high voltage vehicle, and then there's people that can work on a live high voltage vehicle, as in working on the battery, for example.
Yeah.
So, but this is what we've got here. Couple of different systems. We've got what we call a truck train here. So we've got
heavy duty vehicles.
Yeah, heavy duty.
Just go out of the way.
And that's because that's becoming a huge thing at the moment as well, talking about hybrid and electric vehicles that are coming in on the heavy vehicle. The one we'll be focusing on mostly today is this one here, the car train. So the systems here, these ones are very similar. So looking at, this is kind of like the introduction to hybrid and electric vehicles. And the one that we'll be going into detail, we'll have a look at a few things on this one today as well, but we'll be going into much detail with this one tomorrow, is the high voltage battery. So this one here might look like it, but is actually a high voltage battery there. The 70 volts, high voltage is considered
60
volts
DC, 30 volts AC.
Exactly. So what I'll have a quick look at though is just for everyone who hasn't seen it before. So I'll just share the screen up here so we can bring that up. Is what the ASE L3 test looks like. So you can get this. You can get this simply online. So go to ASE or search it, ASE L3, and it will come up straight away. Super easy to find. Goes through, as you're probably all aware, the task list, the questions, everything that you need to know. And this one here, this is the task list. So there's 5 different areas that are being focused on.
That's true.
And what I've just pulled out here is having a look at, now I always call this blue, but I'm colorblind, so it's more
it's
pinky.
Purple, blue,
purple, blue,
it's okay.
Purple, blue, you get the idea. What it is, these are over and over again throughout the whole system. So, and it's split up into 2 sections. So we've got a safety section here, perform high voltage disconnect procedure, reconnect, enable high voltage system. Select, test and use proper safety gloves, select, qualify and use proper electrical testing equipment and leads. That's under the battery section, it's under the drive system section, and power electronics and the hybrid supporting system. The exact same thing.
Over and over again.
4 times.
Yeah.
Obviously we don't have it in internal combustion engines. And we're not going to cover combustion engines here whatsoever, because I think most of you
are experts on that
as well.
Yeah.
If we have a look at the yellow system here, it's now retrieve and diagnose DTCs, diagnostic trouble codes, determine needed repairs. Diagnose problems caused by damaged or failed harnesses, connectors, terminals and fuses, and test, diagnose and repair high voltage leaks or loss of isolation. And again, that's over and over and over again looking at that. So there's a couple of standout points there. Safety, of course, is paramount. They're saying understand what gloves you're wearing, understand the measuring devices that you're using, and be able to shut down the system.
Yeah.
If we look at the technical side, retrieve and diagnose DTCs, determine needed repairs. Now, I love that. That's how many words? 7 words. In order to diagnose something, you need to know so much though. It's a different thing just saying diagnose something, but in order to diagnose something, you really need to understand it. And so that's where the theory that we've been talking about before really comes into play.
Absolutely.
So understanding the system is absolutely required at this point in order to diagnose. Isolation. Isolation using insulation testers is a huge point here. So obviously we've got a separated system or an isolated system. The high voltage system doesn't run on the normal chassis system. It has its own circuitry within the vehicle. So if you've got a breakdown of insulation, you're going to have a bad day. So
that's true.
Having that high voltage system onto the chassis. So that's called a loss of isolation or insulation. So we'll do a test there. And that also comes into failed harnesses, connectors, terminals and fuses there. So obviously, so we've got a bunch of equipment here.
The so-called PPE.
Exactly. So
what I really liked about it, and this was also one very important task of the Skills USA, they look all the gloves. So we see here gloves, we see rubber gloves, we see leather gloves, I see measuring leads, and I see different multimeters, let's say that way. So on the first view, everything looks pretty much the same. So basically, when you tell me now, just go there and have a look at it.
You could imagine that's what you could find at the
Absolutely,
store or at a workshop. Someone just gives you a box of gloves and says, okay, go and fix this car.
Absolutely. And the question now for me is, I mean, we are all aware of that we are working with high voltage. So we need a certain level of safety there. So that means that this one, it's like the last defense line, right? In front for the high voltage system, basically. So all the components must be at least able to block the voltage, which could possibly come from the high voltage system, from the car, wherever. So we have to fulfill certain requirements. What are the requirements for this PPE then, before we touch the high voltage system?
What I'll do is I'll just bring back the screen here so we can see. So this is the LabSoft course that we have, which goes with this. And so this goes through the complete theory that's required. So
and that's basically built on the ASE L3 curriculum, right?
It's literally, if we have a look at that ASE L3, we see here battery systems, internal combustion engines. As I said, we'll leave that out. Drive systems, power electronics, hybrid supporting systems. If you see here, we've got the main chapters are literally battery systems, power electronics, hybrid supporting systems. Drive systems is a part of the power electronics. But this is exactly, and we've added introduction. So we want to talk about why do we have electric and hybrid vehicles? And of course, safety has its own chapter there as well.
Okay, yeah.
So if we go to safety there, we talk about risk assessment and things like that as well.
Just one thing, but because I just see it, and we have also repetition for the electrical and electronic fundamentals. As I can imagine that this is very important if you want to touch high voltage, which is on a very high level, speaking of electricity and electronics. So this course also offering like an additional chapter when you see that your students are a little bit, let's say, that it makes sense to repeat some of these topics. That means all the fundamental topics which you need in order to understand the high voltage is in there. You can do it or you can leave it out.
Yep, absolutely.
That's cool.
And that works. We would rather err on the side of caution, add more information than necessary. So it's just like reading a book or a textbook. You know, you can skip some pages if you don't need to cover that in this class.
So I have talked to a teacher and he basically said, wow, what is great about this e-learning courses that you have created, there's a lot of content and you can't do it on 2 or 3 days. But what he loved so much about it is the fact that you do not need additional sources. So basically all the information you need in order to understand high voltage system is inside this e-learning.
Yep. Okay, so talking about gloves before, so we can go through here and we can show exactly what gloves the students need for hybrid and electric vehicles. So the information there is about class 0, 1000 volts rating, and also there needs to be a testing that needs to be done as well. And so that's what we recommend here. We've got all of the different gloves, and that's by design. We do that deliberately, basically to confuse the student, but we're forcing them to make a decision.
Okay.
And so we're giving them the wrong gloves, we're giving them gloves with holes in them, things like that, so that when they go to this point, testing the gloves, they understand, okay, are they choosing the right ones and things like
Yeah.
that.
Shall I do that for that now? Because later on we need them for
So
the...
I'm quite conscious that we've been talking for quite a long time already and we haven't shown anything.
Thing.
I mean, there's a lot to talk about, but what we might do right now, I think, is we'll do an insulation fault on the system.
Okay.
And we'll perform a shutdown.
Yeah.
And an insulation test at the same time.
That's now a very good thing about this. We said before, putting high voltage faults inside a real car is very, very dangerous because you basically can't see and can't understand how the car will react. In the best case, the car just breaks down. In the worst case, the car's catching fire. Everything's possible basically. So that's why you never should manipulate a high voltage system by your own. Furthermore, we have also experienced another problem that was here in Germany, very, very interesting. If you are talking about shutdown procedures, so shutdown procedures are a good method, or a lot of schools or training centers are using that like a test to see if the student has understood the most important task on this car. So, and the thing was there, of course, you don't have just one student doing it, you have a couple of students doing it, and maybe even in a row. So it's like shut down, set it up again, shut down, and you're just going in circles about that. And what has happened here in Germany during a test, they have used a Prio 3, I guess, when I remember correctly, and there they had 10 students, and of course the car was before heavily in use, so they did a lot with the car and shut it down pretty often. And what happened during the test suddenly, that they shut down the car, and for the last 2 students, they want to put it back into operation, and suddenly the car said, stop. You have shut down me now so often in a row, so there must be some really critical issue when there is a need to shut down the car so often behind each other. So what the car did was like, I'm doing nothing anymore. He just, the control units for the board network and all that just shut down and did nothing on that anymore. And basically they have to call Toyota in order to set the car back into operation. What is great about this system, what I've seen so far, you can shut down it as often as you want and nothing happens, right?
Yeah, absolutely. So a little bit of an introduction to the system. This is what we call our car train system. And so what we're seeing here is a way to simulate different types of hybrid and electric vehicles. So we've got a little overview of the different types of hybrids that are available. Things like series, parallel, or series parallel. So series would be something like a range extender. Parallel is like an electric motor, like the old Honda systems with a boost mode, for example.
Okay, yes.
Series parallel is then your Toyota systems.
Prius.
Yep. And electric vehicles and fuel cell vehicles.
Okay, and what have I to do now? Do I have to dismount everything to get from the one system to another system?
No, so what we've got here is just systems where we can change out this overlay mask, and what we can see here is how the system,
this one?
switch that out. And just by plugging in this plug here, we can then identify that as an electric vehicle instead.
So on the whole the whole monitor changed here, and now we see the setup of an electric vehicle.
Yep. So you can see here, this is kind of like the breakout box. This is what we were saying before, where it's a little bit easier to be able to see and take measurements within a high voltage system. So once we've got the system going, we can go through, and what's interesting here, it probably would have been better if I had that one left on there actually. We're looking at how we've got energy flows within the, maybe we'll just switch that back again because electric vehicles are a little bit boring when it comes to energy flows.
That's right. So you see you can do everything on the fly. The system do not crash.
Without that, goes back to a combustion engine just to see what it's like. But here we can see what different types of hybrid systems are. When do we get generation through MG1, MG2, what's driving, what's regeneration, using systems under acceleration, things like that. So this is what we call the car train, and this is what we're using. This is kind of our introduction to hybrid electric vehicles.
And what can I do? I see now I have a fully charged battery now. So, I mean, it's not fully charged, it's inside the state of charge, basically. But when the teacher now wants to have 50%, what should I do?
So you can switch that down quite easily here and see what happens under lower state of charges. When does the MG1 come in to generate a bit of extra power for the system?
And it's the same here with that system. That's always a very interesting point. So when we are talking about 99 or 100%, it doesn't mean that we are using the full capacity of the battery, but that it's used in a certain window. For example, between 30 and 80% of the real capacity of the battery.
Yeah, and that's where, I mean, we don't have time for it tonight because we estimate there's, I mean, it's hard to say definitively, but we've had students run anywhere between 30, 40 hours to go through all of the curriculum here. So, and that's with the theory, but there's over 40 experiments to do on here as well. Okay, so just that's a really quick overview. Like I said, we're not trying to do a product presentation here. We want to do some training. So what we're going to do now is up in here, we can then quickly add some faults, and we're going to do an insulation fault here. So I'll switch that on, but if you have a look over now on the display, we can see that we've got a little yellow triangle. Now the system is running as we see it right now, so it's still continuing to drive, and that's kind of state of the art now.
Yes, exactly.
Earlier vehicles would shut down when you get an insulation fault, but what they'll do now is they'll continue to run, at least so you can continue to where you're going, depending on what type of insulation fault and where it is.
Absolutely.
As well.
And this is also what the color will tell you. If you have the yellow one, you have a problem inside the high voltage system, but it's not absolutely critical. When it gets red, then it's like that the high voltage system will shut down because you have a really serious problem then.
Yep.
Speaking of serious problems, we just see now that you have activated, just by flicking the switch, you have activated the fault. So maybe the teachers are, or the instructors are a little bit afraid that students can do that. When we close the door, we can lock it and get it away, so no one else can exit it.
Yep, absolutely. Okay, so what we're going to do now is do a typical look at how to go through an insulation test. What is an insulation test? But we'll also then do a shutdown procedure with that while we're doing it at the same time.
So the car is coming into the workshop.
Yep.
And we'll park there.
Exactly. So what we've done here, what we're saying before, Christian, you were talking about how the systems can be a little bit overwhelming when you're looking at a full vehicle. Our philosophy here is to kind of take out those systems, place them onto a training system like that, so it makes it a little bit easier to understand. Also, we're talking about scan tools before. This system now is, I think, 9 years old. So it's in the 4th generation.
Yes.
We keep updating it as technology updates, but the concept is now 9 years old.
Absolutely.
And so especially back in those days, there was very little scan tools that would communicate with electric vehicles.
Yeah.
So we just built one in here so that it was a little bit easier to access.
So that means you see here the small OBD interface, and we just push it, and then you see that the diagnostic tester is open.
So what we've got here is we've just got one fault. We also don't want to overwhelm the student as well. So sometimes if you're using real vehicles and you put in a fault, especially in a high voltage system, you can trip dozens of faults at the same time. And so we want to make it a little bit more easier to understand. And so we're just focusing on the one fault. P3009. High voltage leak to ground at MG.
Exactly.
So, do you want to do it? Should I do it?
We'll just do it together. I just would start, okay, we have now the fault, and we have now to find out what is wrong in the high voltage system. First thought which we should do, what do we have to measure? When we are talking about insulation, we are talking about resistance, electrical resistance. There are also a few traps which can happen there if you use the wrong measurement tools, but at least what we can agree on, we have to do resistance measurement basically. And we all know when we do resistance measurement, we have to get it voltage free. So this is now the point where we should start. with the disconnect process and shut down the high voltage system. So we leave the tester here. We have seen the fault is there. So first thing what I would do now, we are still in ready mode, so that's not good. So we shut down the ignition. Talking about the key. I mean, we have here now a classical key. Let's get it in focus. Yeah. So that's not a main issue if we are keeping that close to the car. But what about well, we had this Tesla here, and this Tesla had kind of a smart key basically. So what's the issue there, or what's the dangerous there?
Well, we know most vehicles have smart keys now, but we decided against that here because it's a training system. We didn't want students, because we need the system running when students are there, and if it's like a smart key of some description, they go missing pretty easy. So that's why we've got that type of key. But one of the things you really need to look out when you're doing this in the workshop is go back and press the ready button. So if the physical key isn't there, go back and still try and start the car.
Yeah.
Because you know what it's like with some customers, they're going to put a spare key in the glove box or in the console or something like that. I had a guy tell me he found 4 keys inside the car one time, kept on doing it, and removing it, had to go through and look for them. Interesting fact that I've tested a couple of times is we put the smart key in a safety lockout box like this. So if you're not familiar with this, I know this from the mining industry, where you put your key on there, your padlock, which has your name on there, and you're the person with that key. We can have up to in this case, 12 people working on that, so no one can access the what's inside until the last person has removed their key. That's the point of a safety lockout box like this. But I've tried putting the smart key inside these, with me inside the car, and then press the start button, and it doesn't work. So it kind of acts like a Faraday cage for the smart key. But important, always try and start the car.
Because I had at a training the other case that I assumed that it was a Faraday cage.
Oops.
And it still worked.
Okay, so don't assume.
Exactly, like you said, always put it away, don't put it in the cast, lock it in the box, put it like 5-10 meters away and really test it. And if it doesn't work, good, then we can go to the next step.
Yep. So, next step.
The next step, okay, what do we have here? I mean, it's always about the car manufacturer rules, but always a good point is, at first also to check that it's not charging cable at the car. That's very important. So that's not the case. We see here, we have our charging connection over here, but it's not in use. We have shut down the ignition. We have read the fault memory before. So the next step would be now to disconnect the 12-volt battery.
Yep.
Of course, we do not need gloves for that. We have here just 12 volt, and we have here fast disconnect. So that means we can just go here like that and disconnect the minus pole.
Yep, so you can put that in a side, a little plastic bag or something like that if you really want to make sure it's completely safe then. Okay, next step then. So we've got the vehicle. That should have shut down the vehicle. It should have closed the system main relays, which is the system main relays are what disconnects the high voltage battery from the rest of the vehicle. So
exactly, so they should be definitely open now, but we do not know at this point.
Okay, next step is we've got the high voltage service plug here, and something down here is what we're calling the inspection point, so the high voltage inspection point, and that's where we can go in and actually measure that the high voltage has dissipated. So this here is somewhere after the battery and after the service plug, where we can then go and test.
Maybe at this point, a quick information. We have here the European version now. For the US, we have a special US version. Of course, here's everything then in English.
Yep, that's true. So now we need to decide which gloves we're going to wear.
Okay, you said something before about the class. So it's class 0, 1000 volt.
Yep.
We will have a look if I can find them. That looks good. Class 0. Class 0. What do we have here? That's class 00. Okay. So I assume that's not good because it's just up to 500 volt. What do we have here? Same class 00.
And that was really interesting. We had, I would say, so you and I were both there, Christian.
Yes.
I would say at least half of the students selected the wrong gloves. we had 4 pairs of gloves at Skills USA, that is. So that was really interesting for me to find that they were just they literally just pick them up at random and threw them on.
And we don't do that here because we have another class 0, 1000 volts. So the red one and the black ones looks to be good right now. But there are clearly, like you said before, there are some test procedures which we have to run through. So we have now make sure that the class is correct and the voltage is correct, basically. So they are gone, they are not gone. So we have now to find out which one can we use, or can we use both, basically.
Yep.
So as you say something about the test procedure.
A couple of critical things is the date, to make sure that the date is. Both of these have the correct date on them. And so you might have seen this before. I'll try and get it in the screen, but to really put lots of air, roll them up and put them under pressure to see if there's any air that leaks out. What's really interesting here is there's also the pump, which you can pump them up with.
Yeah.
And we've tried putting pinpricks in these, and it's actually really hard because it's thick rubber. You've got to put a lot of pressure in there, so it's not immediately obvious that there is a problem. So you definitely, just doing a simple little, not very tight roll is not going to do it. So you really have to put it up, and then even put it up to your face to hear it. We've actually put quite big holes in these before, and you don't notice anything.
Oh, that's good.
But these ones here, both are fine. And what you've got is a difference. So in Europe, we don't use the leather gloves.
That's right.
In the US, we do have the leather gloves.
So you're talking about these ones?
Yep. So they have no insulating benefits whatsoever. They're literally just about protecting the rubber gloves, which I think is a great idea.
Absolutely. But there's another challenge. Of course, it makes absolutely sense, because when you get with these rubber into sharp edges inside the engine bay or something like that, you could easily destroy it, without recognizing it. But with these rubber gloves, of course, you are not running into that danger. But what is important about that, you have even one more layer on your fingers, and now you have to do different operation measurements using tools and all that. Therefore, it's also so important really to train that, to work with these gloves on your hands and doing, sometimes tiny stuff.
Yep, absolutely. So this is where we get to the service plug. So removing the service plug simply like that. And this is what we're also going to put into the safety lockout box.
Yeah, it's waiting for the another. Very good.
Child-proof. At this point is where we put the lock on. There goes my...
something like that?
Yeah.
Do you need help?
Yep, that'd be good. Thanks. So now that's locked away, and that key then stays on my person. So as we say, it's your life, it's your responsibility.
Absolutely.
Christian, can you please pass me a measuring device and maybe explain what is the difference and what are we looking for?
Okay. The thing is that are both Fluke here. So both measuring equipment is from Fluke. They look pretty much the same, but they are absolutely different. So the thing is now, when we're talking about insulation measurement, we want to measure really, really high resistance. So we are not talking about kilo ohm, we are talking about very high level of mega ohm, basically.
It's actually another name for this insulation test.
Meg ohm meter.
Well, mega.
Mega,
okay. Is what some people call it as well.
So what's so important about it, as first for the measurement area, so you need to have a look at these measurement tools. And I try to, that our professional camera girl can catch it.
Thanks, Della.
So perfectly. So there we see now, we have on this one, we don't have like a measurement area for the meg ohm area. But on this one, we do over here. There you see, there we can go down to 500 volt, 1000 volt, and it says clearly insulation. And this 500 volt or 1000 volt is focusing the high voltage, the nominal voltage of the high voltage system, which you're going to measure. Okay, now we know that this system basically enables us to do the measurement. But now we have another problem. Same as the gloves have to fulfill a certain class, it's the same with the measurement tools. So when we have a look at it, what do I see here? I see that it's basically Cat 3000 volt. What do you say to that?
Yep, Cat 3, 1000 volts is exactly what we need.
Perfect. But it doesn't end with the measuring tool, because now we connect some measuring leads to it, right? So, and that means not only your measuring tool has to fulfill this Cat standard, also your measurement leads and any adapters which you put on which you put on top of it, they have to be Cat 3000 volts. In that case, yeah, it fulfills that completely. And furthermore, we have also to check that there is no damage at these measuring leads. We have here a couple more measuring leads, which we have prepared as well. You see here, for example, that's a clear, yeah, perfect. So I think everyone would sign that he can't use it. So now we connect that. I just have to connect it correctly. Insulation.
Before insulation,
you're right.
we have to make sure the system is now safe to work on.
Very good. So that's what you said about the live dead live measurement.
So what I'll just show you here is I'm going to now remove the high voltage inspection point. And because I don't know if the system is free of voltage yet, so I'm using the high voltage gloves here. So at this point here is our two little terminals for the battery. So we'll show that to the camera maybe. What I'm going to go down here is go to the battery. This is the live of our live dead live test. So I'm testing on the battery here. Now what I'm going to do here, using a one hand rule. Obviously if we use two hands, we can make ourselves, if we make a mistake, we can be a part of the circuit.
If you make mistakes, or even when the gloves have a problem, which you haven't seen.
Exactly. So go down and then measure at the high voltage point and make sure there's 0 volts. Sometimes you might get 1 volt or 2 volts or something like that. That's okay, as long as you're not getting the full voltage. But now to go back and make sure that we haven't just exploded our multimeter up and got a false positive or a false negative, I'm going to go back to the battery and just make sure that I've still got 12 volts, that the multimeter is fine.
So and that's important even, there are some pictures in the field which shows that people are testing the voltage as a power socket, for example.
Yeah, that's true. So can go up and measure, for example, 110 volts at the power, just to make sure if that's okay. But really that's not acceptable because it's AC voltage. You really want to check DC type for type.
And that's why it's so important. We always say there, measure or use the test voltage for the voltage which you will measure then at the high voltage system, and that's always DC.
Exactly. So that's kind of the traditional shutdown procedure that we've just shown you there. So a lot of the vehicles. We're going to also show you some of the newer ones using low voltage and even a scan tool, what that looks like, because that's quite interesting. That's what we're starting to see on newer vehicles. Now the system is safe. I can now remove my gloves and work on things like the inverter, non-live high voltage.
Yeah.
And so, but we want to now do an insulation test.
What do you say to that thing? What I've heard before, I mean, there are different opinions on that. If you do an insulation test where we use high voltage, basically at this point, does it make sense to wear the gloves or not?
It depends. It makes sense. Definitely makes sense to wear the high voltage because let's just do a little test. We'll see if we can see.
Say when I should.
Yep, do the test. We're actually getting a little high voltage spark coming across there.
It says,
Yep. So it's definitely, it's like a little taser. It's literally putting out 1,000 volts here. So what we can do here, for example, is we can go along with a normal multimeter, test this, and we'll see, okay, we're not seeing any resistant faults whatsoever. And so, but what we can do here now is we can go to ground and, for example, go over to, it just said MG.
Another question, when we have different voltages which we can choose, which one should we use, or how do we know which voltage we should use for our high voltage system?
You should always read what the manufacturer says.
Okay.
So yeah, some specify 500 volts, some say 1,000 volts is okay.
So at this system, we know that we have a maximum voltage of 300 volts, so we are fine with 500 volts then.
Yep.
Okay, cool.
Also fine with 1,000 volts if we need to.
Absolutely, yeah.
Yeah. So,
can I go?
Yep, do the test and we can see, and what that's doing is putting out 1,000 volts between here. Now we're running onto motor generator 1 and the ground. And what that's telling us is that so it's not giving us well, it's giving us both. It's giving us a voltage and a resistance reading. So 500 mega ohms, 550 mega ohms.
Above.
So that's actually the limit of the device. So it's well above. And 500 volts, it's showing that, or here, 660 mega ohms.
I'd switch now to 1,000 volts then.
Yep, so 1,050 volts is where it got to, and it still didn't break down. So we've got insulation resistance to that. So that's telling us that motor generator 1 is fine.
Why shouldn't we measure the other ones?
Because if we have a look at the motor generator, it's in a star or a delta fashion.
Yeah.
And so that means all of the phases are connected together. So if we measure 1,
there's a fault.
We're going to be measuring all 3.
Okay, that's good.
So if we then go to MG2.
Oha.
And we can see here, there's a real problem. So this is now
300,000
ohms. So
yeah,
300
exactly.
kilo ohms is what we're showing there. There is a formula for working it out. I think it's
yeah, that was each volt needs
1,000 ohms or something
exactly.
like that.
Yeah,
so yeah, so that's not enough. That's actually leaking out because we've put on a fault there. But that's then showing the student, okay, they've done the test, they've done the shutdown, and they've identified where the problem is.
Exactly.
So we're not about repairing the system here. It's about understanding and doing the fault finding.
Absolutely.
Okay, so what I'll do, we'll put the system back together. Maybe I'll put the system back together, and do you want to do a tester, a scan tool based shutdown
Absolutely.
on this one here? So there's no need to go back through it. We're basically going to show you
the modern way. Let's assume what Daniel has shown you right now. It's like, I would say it's the classical way, the old way, but it's also important when this way, so the tester-based shutdown, when this fails. Why is that important? Because as Daniel has touched the high voltage system and has more or less interrupted the high voltage battery, right?
Yep.
So that means you really had a mechanical access to the high voltage battery, and while you are pulling out the high voltage disconnect, then you have seen that you have literally mechanical disconnect the high voltage battery. In modern vehicles, we do it a little bit different. So there it's so the idea of the car manufacturer is that even the guys in the workshop shouldn't touch as less as possible the high voltage system or the high voltage components. There you will see right now for this tester-based shutdown, I do not need any gloves. Why? Because I'm just touching components of a 12-volt system. So let's see now. We are here in our system and I first try to start it. So I push the brake and the engine start button. And we are in ready mode and we can basically drive the car. No high voltage fault right there. So now we open our tester, as we see here. So on this tester is telling now everything. Of course, we start at first with the high voltage system, fault codes, and we read the fault codes. and we see electrical leak detection sporadically. So we can't see that right now. It doesn't show up here. So it's maybe not such a critical fault, or it's even not there anymore. That's why we delete it right now. And there are no faults right now. Okay, perfect. Nevertheless, we're going now to shut down the high voltage system by using the tester. That means we are jumping now to the special functions.
Christian, I'll just add here, because what we've done is we've shared the screen. If you're looking on the screen, you'll see two different screens now, the screen of the computer plus the camera view. There's a slider in the middle. So if you want to make one screen a little bit bigger than the other, you can just slide that and make them the size that you want them to.
That's pretty cool. So we are focusing here now the high voltage isolation procedure. At first, warning that only experts should do that. We're jumping here. It tells you a little bit what we need. We need also a safety padlock, which I will have here. So it's the same one like Daniel used, but we use it for another kind of reason, which we will see later. So then we go on. Switch the ignition on. So that means please not ready mode, just the ignition on. That means we shut down the car and go back with ignition on. So, and this is, as the information says, it's for a self-test for the internal measurement device. We continue, and now it tells us high voltage system is active because it still can measure the high voltage from the battery, coming from the battery. This is so important right now because now we have a real measurement tool inside the high voltage system which measure the actual voltage right now. We go on and it says now switch the ignition off. So we shut everything down and now it tells us disconnect the green 12 volt service disconnect. Do not remove the orange high voltage service disconnect. So that car has even here the high voltage, the orange high voltage service disconnect, which Daniel has used here at the other training systems. But we shouldn't remove that one. We just focusing this one over here. The Audi, which we have talked about in the beginning, has the same disconnect like this one. We are using that now just by pulling that out. So we do not need gloves for that because we are in the 12 volt area. And now we are just pulling it out. So now we have triggered a signal which tells the high voltage system to completely shut down the system main relays and keep it open. And now, as well as I said, we need the padlock. And this is what we do now here. We bring it through the hole and connect it here. So that means we have now disconnected disconnected the 12 volt system through the, so we have disconnected the high voltage system through this low voltage disconnect and secured that no one else can put it back into operation as long as the padlock is here. Same what we do, or Daniel did with the padlock key here, we keep it at our person. When is the orange service disconnect important? This will be only important when this disconnect fails. Then like a battery expert has to come and has to shut down it mechanically again, that you really have a disconnection of the high voltage battery internally. So now switch the ignition on, just the ignition, so we just press the start button. And now we see high voltage system de-energized. So Daniel, do we need to measure now everything?
No, so that's all occurred internally. So that it's kind of like having that Cat3 measuring devices built internally into the system now.
And I talked to a lot of instructors who were a little bit, or who knew the old way, which Daniel has shown, and they were a little bit like, whoa, I really shouldn't measure anything by hand anymore and I should trust the system. Basically, yes. The system is designed that way that you really can trust it and it really takes a real voltage measurement and it tells you now the system is absolutely safe. So switch the ignition off. And now we are ready to go and can basically, like we did it here before, we can now start doing different measurements, or in that case, even dismount the high voltage battery and everything like that, and do the complete diagnostic and repair task on that, because it's now voltage free.
So that's really important, the step, is because you're leaving the ignition on. So the scan tool can still work.
It has to, yeah, absolutely.
So that's obviously a bit difficult when you disconnect the battery and things like that. So, okay. What we've also got there, if we just go to the zoom in again of that, what's the little yellow plug that you've got underneath there, Christian?
The yellow plug, you mean the stickers, which are as well as the low voltage one, as well as this fuse here.
Yep.
So this is especially for the first responders. Even the first responder, and there's the so-called the rescue card, basically, which you can download and you should print out for any kind of car, and it should be in the hybrid car or in the electric car. And this tells the firefighters, in a case of an accident, when they can't call the hotline of the car manufacturer or anything like that, they directly know, okay, when I open this one, I can get it voltage free, as well as I can, when I pull out this fuse here, I can do it right now. So it's basically, do you see it? Here we are now, okay, perfectly. So this is the fuse, normal fuse is inside the fuse box. The location of this one is shown in the rescue card. And the firefighters just pull it out. They do not touch high voltage in that case. It's like with this one, it's a trigger signal which makes sure that the high voltage battery will open its system main relays.
Okay, so I think the tricky part about this low voltage is to close it back up again. So do you want to just show us
Absolutely,
how that is?
Yeah. So like we say, we stay here. And now we have to open this thing, of course. And now we need the screwdriver. Why is that the case? Because now we just can't or maybe a little bit too, yeah, perfect. Now you see, I can't just push it in again. I need now the screwdriver, and there's a little hole here. Go inside there, and then with a little bit of bending, I can put it back into operation or in its place.
That's it.
And now the system is again active.
So as simple as that. So we've got a question come through. When did manufacturers start using this? So interestingly enough, these used to be orange.
Exactly, BMW i3.
So the BMW i3, I think it's about 2014 came in.
Possible, yeah.
Mostly European manufacturers, but I wouldn't be surprised if we start seeing that in other manufacturers, this type of system.
Yeah, I guess so as well.
ScanTool, I think, is probably 3 years old that we're using ScanTool. Shutdown's 2 or 3 years old. With the low voltage one there, I'd say about the last 5 years old. But they used to be orange, but they've turned to green because they realized that was a little bit misleading having them orange, because they're not actually a part of the high voltage system.
Exactly, and you have learned when something is orange, you don't touch it or use gloves.
Yep. Just to add in here, we're now hour and 10 minutes. We've still got some more to go, so if you guys need to leave, no problem. We are recording this, so we will put a link up probably on YouTube within the next few days, and we'll send that out to you anyway. But by all means, you're welcome to stay here. We could be going for a little bit longer yet.
Absolutely.
So just as a friendly reminder. So a couple of the other things, safety systems. We're still looking at safety systems, for example. Let's talk about the interlock.
Okay.
So if we have a look at the interlock, so those of you that are more mechanically minded,
Shall we
just stop the screen sharing on that one? We'll bring screen sharing back on this one. So I used to do a lot of gearboxes back in the day at Toyota, and interlocks then were the interlock in between the gears. So you've got the little pins which don't allow you to get two gears at the same time. Obviously here we're talking about an electrical interlock. Touchscreens are a little bit tricky. So interlock here. So if we have a look at what the interlock is kind of, One of the conditions which is going to affect the system main relays and how they work. But if we have a look here, this is a simple circuit for a interlock. You can see here we've got a positive 12 volts. Now this could be 12 volts, it could be 5 volts. It could be, we've even seen a pulse width modulated signal in some of these. But in this system here, what we're seeing here is the circuit going through, and it's a fixed current. So it's 12 volt fixed current. And that'll become relevant why that's important soon. As the circuit is going through fixed resistors, what we can see here is we've got the bridge connectors that are what you'll find inside the system. So what I didn't show before, and I'll do this without gloves, I'll remove the service plug. We can do that because it's a safe system. There is, even though there's high voltage here, everything's of course completely safe. So if we have a look inside the service plug, so you've probably all seen this before, this is the high voltage connectors here, but on the side over here is the interlock. So it's a tiny little bridge connector which is just bypassing this resistor that we see. So here we can see different areas. So this is, for example, the inverter cover that we have a look that we've got. Or we've got the air conditioning compressor, which has the cables going to it as well, the high voltage cables. There's some interlocks inside that, and the service plug. So what happens if I disconnect that? You can see then the circuit is then forced to go through the relay, the resistor. And when it does that, because we have a fixed current and a fixed voltage, the resistance changes. So the resistance across these two circuits will change, which changes then the voltage drop across. So, and you can see at this point here, where we've got the voltage drop, measuring the voltage drop, we can see what happens as we disconnect each of these. So that's the interesting part about how the scan tool can diagnose exactly where the interlock is open. So if we didn't have those different resistors, if they were all the same, you'd get the same voltage drop, and the ECU wouldn't be able to tell where the difference was. So, simple little fact, that's how the interlock works. And that's what we really love about these training systems, is that it makes it so much easier to understand that. So, and we can do that here on the system as well. So the big one that we have on especially this type of service plug that you see on Toyota is people will forget to push the service plug down. And so they'll put the service plug in and forget to push it down, which is where the interlock is. We talked before about red and yellow triangles of death, we call them. A fault, high voltage fault. Yellow was it's a fault, but not a critical fault. Red is a critical. That will shut the vehicle down. And here we can see the high voltage interlock circuit at the service plug. And we have that, for example, also on the inspection point. So if we remove that, it'll also trip out a fault as well. So I think that kind of fits interlocks. We don't need to talk about that too much longer. That's,
exactly. So
pretty
basically
simple seeing it like that, I think.
Yeah, pretty simple, but pretty important. I just think about this one video. I don't know if you want to show that.
Which one?
Which shows when the interlock is not there.
Yeah, let me find that.
I think it's pretty at the beginning. Shall I help you?
Here we go.
Exactly.
So, need to yep.
So I think that's a very interesting video, because there, especially for the students and the young people, when they just hear that in the theory, there they see something, for the practical, but which you shouldn't do at home or in the class.
This is a cable with 300 volts going through it, 300 volts and 10 amps. And the interlock has been disabled and the cable is slowly being pulled apart. So you can see what happened with just 10 amps. A Prius will have 120 amps at full acceleration. So that there is just what happens if interlocks have been bypassed and things like that as well. So that's why it's so important.
Or if there are no interlocks, because there are still cars on the road which don't have this intrinsic safety. And then it could happen that they have basically no interlock. For example, also heavy duty vehicles, that could be as well. Is there a question?
We've got some information come through from Brian. This is possible, and I stress possible, with any system that uses a disconnect that is not directly on the battery. At Volkswagen, we do not currently trust this and do still verify HV status with a standalone tool.
Okay, that makes always sense, basically, yeah.
It's really important to verify, and here in Germany, for example, that's in bold written in the standards. You must verify that the voltage has dissipated as well.
Absolutely, yeah. It's like a protocol which you have to sign.
But I think the tendency is that the manufacturers will want to go more and more to working with a scan tool as opposed to
absolutely.
That's
for
not
sure.
necessarily the best thing, but that seems to be the way that they're going.
Okay, now you said the interlock. So basically, when we open the interlock, we coming to the point that the open interlock will lead to an opening of the system main relays, a forced opening of the system main relays. So what are the system main relays basically, and how many do we have? So the system main relays we see now very nice over here in that area. That are basically 3 relays which are the border between the high voltage system and the high voltage battery. The high voltage battery will always be under high voltage, but the high voltage system won't be when the system main relays are opened. And we have 3 different ones, which we call the minus high voltage relay, the plus high voltage relay. So that are the working relays when the high voltage system is booted and we see the ready sign, then these 2 are shut. But before the high voltage plus relay will be shut, there is a so-called the name was pre-charge relay. Exactly. So that means there is a resistance inside this wiring or inside this connection, which we see here in the animation as well. And this one leads to that it charges the capacitor on the one side, but also do like a safety check. And with the safety check, you make sure that the system works fine. And as soon as when a certain voltage is reached, then the pre-charge relay will open and the high voltage relay will close. That it really goes to full voltage and to the ready mode.
Yep, absolutely. And so with this system here, we've got it on this system as well, but this one here we can actually show the relay switching on and off as well at the same time. And
that's a cool thing.
Yeah. So you've seen the animation going in the background there. Have you set all of the...
I think so, yeah.
Yep. Very
Why not? Cool. I'm the one to blame.
Yeah, always. So that there is essentially a really cool... That is showing you what happens during the ready mode or startup on the high voltage system.
Absolutely.
So from this here, we can actually take a lot of information. So if we have a look here, we've got 4 channels. So as Christian was saying, we've now set up high voltage is looking across the high voltage of the system, and that's this dark blue. So we can see the voltage going from 0. That's also set at 20 volts per division, so 20, 40, 60, 65 volts there, roughly. And we can see the slow curve going up to a point, and we can see some action going on with the relays in the background. And then the high voltage comes up. So what I'll do here is bring down, oh, look at that. So, and then once we're at the high voltage, we can see this shutdown. So both of the relays have turned off here. We've got a slow discharge going on there. That's called passive discharge.
Yeah.
And then straight away, we see the voltage drop down, and that's active discharge. And so there's various methods for showing that, but that's this very short diagram tells you a lot. So for example, then if I bring down some of these various, just so that we can separate them a little bit here. So this here, for example, just by looking at that, I can tell that is the main relay. So because once we switch on the system, we know that the pre-charge relay is switching on, and we know that the negative relay is switching on, so that we can see, okay, yep, that is. So this light blue one here, this one, that must be our pre-charge relay, which is switching on and off, because it's switching on with the main relay, and we can see that time coincides just here with, so the main relay switches on at a certain time, and we can see the voltage shoots up, and then straight after that happens, the pre-charge relay then switches off. We're left then with the negative relay, which is switched on at the whole time, and then that obviously towards the end, negative and high voltage positive switch on together, switch off together.
Exactly.
So obviously this is also pretty difficult on a real vehicle to see what's going on there, and we've actually got a new system in development here about this, because we've seen that
That's true.
The technology here has taken another step forward now, and there's self-testing that goes on of the relays at a stage before that. That's brand new technology, so we're developing a new system to show that, but essentially we've got relays switching on, off beforehand to test to see if the
Relays are welded shut or something.
exactly, the relays are welded shut.
And that's also what you said right now, it's very important. This is one fault which we can simulate with this system, which we will see tomorrow in more detail. There you can simulate when you do the tester-based shutdown that the relays have a problem and that they do not open, that they are welded shut basically, and you can't take away the high voltage from the high voltage system. And this is now a serious case where a high voltage expert has to come to the system with all the safety equipment then, of course, because you say the car is not intrinsic safety anymore, and this is where you then have to use the high voltage, the manual high voltage disconnect in order to shut it down and to take out the high voltage battery, for example. So that was, I think, the most important parts about the system main relays, what can happen to them, what they are doing. And this is the unique thing here that you really can see and measure it, that, because this is basically not possible at a real car, that you do the measurement on a system main relays at a real high voltage battery. There are maybe some options through a tester that you see the status, but really measure it, this is a unique thing for a trainer.
Okay, so we had a question that came through as well just before, Christian. So someone asked, what are the manufacturers? So often with ASE, they'll say that there's a sample car, as in what is the vehicle that the test is based upon. So, for example, you've seen it before where they'll specify what does the vehicle have and things like that.
Yes.
They often talk about essentially the Prius, the Toyota system with a series parallel type of hybrid system.
Yes.
But it's very generic as well. It just talks about hybrid and electric vehicles. It also doesn't pay to get too hung up on the naming of strong hybrids or weak hybrids, mild hybrids, or the series hybrids. Everyone has their own definition.
Absolutely.
We've heard the Chevy Volt can be a hybrid or it's an electric vehicle with a range extender. So, but the ASE L3 is kind of generic, and as you can see here, we keep to a very generic standard as well. Okay, so we've gone through a lot. If you've got any questions, please let us know. As always, we'll open up to a live Q&A at the end if you want. But I think we've taken a lot of time already, but one last topic that we'll go into, I think, is electric motors. So
with a great animation,
Yeah, so what are electric motors and how do they work? So I'll just come back onto our thing here. So we've heard a lot about electric motors in hybrid electric vehicles, induction motors. There's all sorts of different things here. We've got induction motors, which is what Tesla kind of made famous. That's the sorry, someone's pointing at me. The Tesla with their induction motor, which doesn't have any permanent magnets inside the rotor. Most other manufacturers use permanent magnet motors. So we've got things called synchronous motors. That's the ones with the magnets inside. We've got asynchronous motors, which are the ones with
Squirrel cage.
Squirrel cage, exactly. Squirrel cage. It's a funny term, but when you look inside the motor, it kind of looks like a cage or a hamster wheel, I guess is probably another way of...
Oh, some pictures of these ones are in the course there.
Exactly. We can have a 2-hour webinar just on how that works.
Absolutely.
And what it is and how regeneration occurs, things like that. But there's a lot of misunderstanding out there about how regeneration works.
Oh, yes.
And things like that, but essentially we'll keep it pretty brief tonight. And look, if you tell us in the comments, in the chat, if you want a webinar on electric motors. We've got loads of info. We could, if you're interested, we could do an hour webinar just on electric motors, going deep dive into different types of rotors and things like that. If you want that, let us know. We haven't planned it, but we could plan it for another time if you're interested.
There was another question, but maybe you just go on.
Yep. So, 3-phase electric motors, what are they? How do they work? So we're not talking about starter motors here with brushes and things like that. We're talking about, induction. So in this case, we've got induction through ASE 3-phase that we are using into coils. So we've got the stators and we've got the rotors inside the motor. If we use the permanent magnets or these induction motors, essentially it's the same thing. So we've got but how does it work? So if we have a look at this right now, if we look at one phase, so AC coming in through a coil is going to create a magnetic field. So that magnetic field is either being repelled or attracted. So obviously we put positive into a coil, it's going to pull it in, and if we go to negative, it's going to repel it. We then put a second phase in with a phase shift. So we've got a phase shift. So the phase shift is the frequency of the imported voltage, but we've also got a physical shift of the coils around the motor as well. But here we can see the interaction between these two. If we go to the 3 phases together, all 3 of those phases are 120 degrees removed from each other, physically and with the inputted voltage. And the result here is the magnetic field will be at a constant speed. The battery is at a constant speed as it's turning around. Sorry, we've just had a bit of a technical fault here. So this is what we've got here is the...
No, it comes back. You just touch the cable.
The cable is not so stable.
Okay.
The cable is not so stable, that's right.
Sorry.
Just push it in.
Yep. Sorry. Oh, I think it's telling us we've been going too long.
The HDMI
All right.
is not so.
Sorry about this. Losing our display. So, essentially here, with the interaction of those 3 phases, we've got a constant magnetic field which is turning around. And that's where the magnetic field comes from to turn the rotor. Now, the question which I stated before was how do we get that magnetic field, or how do we get the AC input into that stator to create those magnetic fields? So here, talking about the different types of motors, what they look like, what the stator looks like as well. How are those coils separated? So we don't just have one coil in the electric motor. Here we've got 6 of each phase, but that could be 12, could be 24. So you can see how that's made up into the electric motor there. and how it is, but we'll go down to, at this stage, DC to AC conversion. So obviously we know that we can do that through electronics and something called the inverter. So the inverter is then inverting that signal. And what we can see here is a pulse width modulated signal, which as the on time of the signal gets bigger, obviously the average voltage that is being output also increases. So you can see here that we can create an AC. So the AC, the sine wave there, is the average of the current. That's the current that's flowing through a circuit there. But the digital signal